Sorry. Okay, so between the two of you, I want you to go through and take the data that was on there and figure out stuff, and then we will debrief about what's going
on.
Wait, it's saying that
But
A is the
if it's straight, then it's assuming that like right after passing the first guy, it's essentially, yeah, he was going 42. It assumes that right after going 42, he's instantly going 60.
All right, guys. So some of you are done.
Sped up. But then
Anyone do the
for the second guy.
first one? Go ahead.
Like that, and that's like the average of the straight.
So this is just collecting the data. So what's the time difference between the checkpoints?
30 seconds.
And what's the distance traveled? 0.5, half a mile in 30 seconds. So there's the graph. What's the slope of the line? What'd you guys get?
Do you want it in miles per hour or miles per second?
What makes sense? So the slope given, it's that many miles per second. What is that in miles per hour? 60. Maniac, she should be locked up. We love this. Okay, so she's doing 60 miles an hour. What did they say the posted speed limit was? But she was doing, clocked at 42 and 43. Yeah, doing an average of 60. How's that possible? So first, can her speed go suddenly from 42 to 50 without doing all the other speeds in between? No. So it's a continuous function. You can't go chunky numbers. Okay. So the speed in context, she's doing 60 miles an hour by that average, right? Massimo, how do the speeds compare?
I mean, it's 15 over the speed limit.
Yeah.
Okay. So the secant line, that average, is that actually how her speed, her position was changing? So can someone draw what they thought her actual speed was? Yeah, go ahead. And I didn't put, like, are we graphing distance? Are we graphing?
Well, we're graphing distance still.
Okay.
Something like that.
So what do you guys think? Anyone have a different one that they drew? What? Any? Yeah. Previous years, people drew. Oh, it's not going. That. Does that work? Why not, Cecilia?
Because it has to accelerate first, and that one is just like decelerating. Like, I don't know.
Well, it's Sasha.
So we're moving backwards.
So position wise, I mean, maybe she drove past the checkpoint and then came back and was like, hey. Alex?
Well, it starts at a ridiculous velocity. It starts well over 60 miles an hour.
If you've ever seen Katie Harvey driving in our parking lot. Yeah. So it's okay, could be something like this. So you graph something like that.
Well, it meant to be a little bit more balanced.
So she, okay. Can you sketch a tangent line that is parallel to this original line? So tangent to the green one, but parallel to the blue one. Is there anywhere else? Okay. So what for these tangent lines to be parallel to the blue line, what does that mean in physical stuff? Okay, so that slope is the average speed, and these two are where the instant speed equals the average speed. Does there have to be a place where the average equals the instant if your function is constant? Nick says yes, Sydney says yes. So thinking about that, you were at 0 and drove for a few hours at, I don't know, in 2 hours you traveled 50 miles. Were you doing 50 miles an hour somewhere in there? Yeah. Was there somewhere in there, if you started at 0, that you had to have been doing faster? You started at 0, but your average was 50. Don't you have to get up to speed and go a little over that? So this maniac, she had to be doing a lot faster. No? Yeah, maybe. Good morning, it's Friday.
Never mind. Not 2 hours.
Okay, so a secant line represents what kind of rate of change? Average. And the tangent line is instant. So Josh, what did you guys say for 11? In a few sentences, describe the speed of the truck between the checkpoints.
We said it like sped up like after checkpoint 1 a lot and went way over 60 miles per hour and then slowed down before arriving at the other checkpoint.
So right after checkpoint 1, as soon as you pass the photocopy speed, you see the next one coming up, you hit the brakes. Okay. Mean value theorem says if a function is continuous over a closed interval and it's differentiable, is speed different, or is velocity, could there be any discontinuities or corners or things that a continuous smooth function should be? So if the function is continuous on a closed interval and differentiable, there must be a place that the average equals the instant. So that's what we need to know from this. So those of you who don't have the actual copy, can you write that in your notes? Mean value theorem. Normally finish this in class, but if we don't, this thing is homework. Some further investigation.
Who is Katie Harvey and why is there?
Katie Harvey was the principal when I first started here. Oh, everybody should have one. So. So does everybody have one of these? Yes? Okay. So, the hard thing is the back of the sheet, but just to make sure we're sort of on target. Jasper, if a car travels 50 miles in 2 hours, how fast was the car traveling over that 2-hour period? 25 miles an hour. Do you know that the speed of the car is 25 miles an hour the whole time? Could it have been slower? Could it have been faster? Okay. So you just know the average. So do we know that the car had to, like, what's the likelihood that it was going exactly 25 miles an hour the whole time? Pretty darn low, right? Okay. So, you know, road trip, potty breaks, make it easy, you might need something. Okay, this one I want you guys to like think about, like, and write some words down. And it's easier to see in color up here. I'm sorry I didn't photocopy well. So talk with your partners. This is distance traveled, and that's time. What is the person or the bike or the car doing if it's going along the red curve versus the pink one versus the blue one versus the green one? So talk it over, write stuff down. Yes, Mary. Oh, sorry.
Man, that was going backwards. That one. Yeah, that position is constantly decelerating. Wait, no, it moves back down. It starts at a high distance.
Doesn't necessarily mean that it's going back to the 20s where it is.
Like, it moves backwards.
But it's the slope.
Yeah, I know slope.
So it's going back.
So, but if the slope is negative, it's going
It's going backwards at constant
just
position is
That's how it is. Doesn't tell you about where to go.
Tells you it's in the negative.
Yeah, tells you it's like
Going backwards.
behind where it starts, basically. Or it could have started in the negative. Like if it's comparing to a bunch of other things.
Get that.
Starts accelerating and then
Yeah, it accelerates and then it decelerates, but it moves forward the whole time. Slowly goes, or fastly goes backwards.
I think
It's slower.
Like decelerating. That's where the
it starts really fast.
Oh, it's like it's
It starts accelerating.
That's why the other ones were because that one just was decelerating the whole time because like the slope is destination.
So it starts out. It's
Yeah. Oh, are you saying since it starts?
Yeah.
Yeah, like the rate of speed is like it's just decreasing.
it moves and then it goes backwards and then it goes forward and then it goes backwards again.
It's still going forward.
It's yeah. Like slow acceleration because it's
Yeah. Speeds up a bit, turns around, moves backward at like a lot of motions. Start speeding up.
I just said decent.
Where? Here?
Or it goes forward. This four is pretty late.
Yeah, and that one's like accelerating a lot. Like after that.
I guess fast.
It's,
It's slowing down. Yeah.
Does anyone want to put up what they wrote for one of them? Pick a color, any color. Luke, do you guys have one that you feel good with? Red?
But it's not position, it's speed. That's the,
Yeah.
the positions could be like.
Or you could use the back of the pen. If you want to write with the pen, you gotta use the back of it. The front doesn't work.
They want it to be safe. Oh, no,
So we don't actually know if it's like if it's going what way. It's gonna see if
Yeah.
Okay. Does anyone else have something to say about the red one? Said it's speeding up and going to the right, which I'm calling the origin home. So it's speeding up, going away from home. Anything else about the red one?
Constant acceleration.
Constant acceleration? Like meaning it's always going faster and faster. Do you guys agree with that? Nick, how do you see that?
Because you could tell that the slope is constantly increasing.
So the distance traveled in each second is getting more and more each time. Okay. Anything else you want to say about the red one? Okay. Anyone want to write up what the blue is doing?
They're slowing down, they're also going backwards.
So you said they're starting away from home or like, and you say they're slowing down? How can you tell it's slowing down?
Because the curve flattens out.
I have no idea.
Because, ooh, The derivative, the slope. This is position. What's the slope of the position? Velocity, right? And it's going to be negative, so the velocity is getting less and less till the end. And then it's, yeah, okay. Alex, what would you say about the green one?
The green one is going away from home and starts out fast and then constantly decelerates.
Okay. And for Mr. Jacobs, there is really no such thing as decelerating. I realize all of us as like passengers in a car, we're the center of the universe. So when you hit the brakes, you say, I'm getting slower and slower and decelerating. But that's because you are only concerned about your particular direction. Deceleration is not a thing. Like it's got a magnitude and a vector. Deceleration is already implying a particular direction. So don't use that word. Craziness. What's the pink thing doing? Where did it start?
Like a rest stop.
It started at a rest stop. Okay. Then what did it do?
So I forgot their coat at like a previous rest stop, so they went back.
So were they moving in the first little bit?
Yeah, a little bit. No, not there now. And they moved a little
That
bit.
little bump. They moved a little bit.
Yeah.
And then you said they forgot their jacket at a rest stop.
At the previous one or something.
Do they do it quickly? Slowly?
I mean, compared to the rest of the journey, it's pretty slow.
Went toward home in a comparatively less fast. What does he mean by that, Sydney? He said compared to the rest of the stuff, he's not going backwards very fast.
Because the slope is smaller.
And right here, what is happening there?
It's a very steep slope.
Steep slope, steep change in position, which means
Moving quick.
moving very fast. So among all of them, is blue moving fastest here? Is green moving fastest here? Is green moving fastest there? Is pink moving fastest here? Like, which color has the fastest speed as a general thing? What would you think?
Pink.
Pink? Because it's got the sharpest line, steepest slope. It's going fastest. And Fiona, how would you explain this? What the heck is going on there?
Well, like they sped up because they I guess wanted to get to their destination. They were going really fast, and then all of a sudden they were like, "We're gonna go home," and so they just like started.
Okay, you pick your kid up. They like, I don't know. You go this way, and oh no, Mom, I forgot my ballet outfit. Oh wait, found it. Never mind. We can go back. Holy crap, you're late to the thing, and we drop you off, and oh no, the dinner's burning. Yeah. Right? I don't know. Become a parent. That's gonna be you, and you're gonna get a speeding ticket here and here. And now that they're little photocops, they're everywhere. They'll get you. And they don't care as long as you pay it. Okay. Here's the real questions. Can you interpret these? So think about them, talk them over before you answer. So, Ethan, just to make sure we're looking at this, can you read us what this says?
I can't really read that one.
Oh, you can't read it there. Okay.
Oh, it's on here. Okay. Oh, right, it is. Oh. The given graph represents speed for two cars. Assume the cars start from the same position and are traveling in the same direction. Use this information in the graph below to answer the following questions.
So this is speed of car A and car B over time, where this intersection point is at 1 hour. So talk it over. What is the relationship between the position of the car, A and B, in 1 hour? what's the relationship of the speed of the car A and B in an hour? And what's with their acceleration? How do they compare? And the last question is the one I really want to know. What do you think is going on between 45 minutes to an hour? Is car A pulling away? Is car B pulling away? Are they closing in together? What's happening? So talk it over.
Yeah, I mean, so it's like an inverse relation at this point.
Yeah, I was thinking you're right, because they're reflected over the y axis. Yeah, they're always
Car, so it's like a steep graph.
like this slope.
No, they're
Car B is accelerating, but I think car A.
Yes, yeah, they're like they're reflected over the y axis. Yeah. So I think the position's the same because they're like
acceleration. Car B is accelerating
when
fast.
car B accelerates, car A has it slowing down already. It's so fast.
Okay, so a lot of people are done. Let's see how many of you are right. What is the relation of the positions of the cars in 1 hour? Alex, you know? Okay, so Alex says car A is well ahead of car B. Does anybody agree with that? Anybody disagree with that? Okay, those that have a counter argument, what's the counter argument? Are they in the same place? Okay, Alex, can you explain why you say car A is well ahead? Because it intersects. What the heck, man? Are they in the same place?
They're not.
They're not, because what is the graph?
Well, it's speed over time.
Speed over time. So
Yeah, you can kind of see car A has been going at a much faster speed for a long, like just looking at the graph. Just car A has been going at faster speed.
okay, so hearing Martin speaking with his group, he also was like, well, car A right here is doing like 50 miles an hour, where this one's got his little training wheels on doing like 10 miles an hour. And car A is going faster for longer, so it's traveled more distance. Anybody in physics? How would they say, like, visually what you're checking? To see velocity versus distance? Area under the curve. So the area under the curve of car B only colors in that much stuff. And those of you who don't know this, don't worry. We're getting to integration soon.
Is this integration also the area under the curve?
Yes.
Yeah.
Yes. Okay. What's the relationship of the speed of car A and B in 1 hour? They're the same. That is true. What about the acceleration of car A and car B at 1 hour? Car B is finally going faster. In the end, though, what's happening to the two cars? Are they pulling away? Is the B catching up?
Car B is catching up. Well, after 1 hour, catching up, but before 1 hour, car is
Before, in the time window asked, car A is still pulling away.
Do you keep this?
Yes, you keep it. At this point, once we cross that point, now car B is catching up.
Because the slope there doesn't, it's just the value, the value below.
Yep. Tricky.
Yeah.